In this video, we're going to solve 5.13, which requires us to find V naught and I naught. So in the beginning, what is the easiest thing to find? I have a voltage source here and two resistors, and I can find the voltage here, VA, at the non-inverting input. What would VA be? Voltage division of the 1 volts across those two resistors. So VA is, and we're interested in the voltage across the 90, right? Because it will give us VA. So it's 90K over 10K plus 90K times the voltage that is being divided, which is 1. So VA will equal 0.9 volts. From the characteristics of ideal op-amps, we know that VA here is equal to VB here. What will VB be? VB equals 0.9 volts. You can also find VB in terms of what? In terms of V naught. Look at this circuit right here. What is it? It's the V naught. And then what? And then you have two resistors. So if I know the voltage here, okay, it should be the voltage here, right? So it is divided across those two resistors. And here for VB, we're interested in what? In the voltage across the 50K. So writing, and this here is your V naught, right? That is being divided on those two resistors. So VB in terms of V naught is what? VB is equal to 50K over 50K plus 100K times the voltage that is being divided, which is V naught. So if you simplify, VP will equal to 1 over 3 V naught. We have the value here. We have this expression here. So 0.9 is equal to 1 over 3 V naught. So V naught is equal to 3 times 0.9, which is 2.7 volts. So we found one of the parameters that we are asked to find. Now we need to find I naught. To find I naught, notice that it is going out of the op-amp here, and it's splitting here and here. Call this IV, and call this IB. Why did I call it IB? Because this current here goes, all of it goes where? To IB. You can name it whatever, but I chose to name it IB. Because here there is no current. 0 ampere. Right? The current here can be expressed in two ways. The current IB. So it is either V naught, here, this is the voltage here, V naught, minus VB over 100, or directly you can get it as VB over 50K. Okay? Why? V equals IR, right? So you can express the current by dividing the voltage over the resistance. Now, I naught, let's write what we just discussed, is equal to IV plus IB. Again, you can call it I1, I2, whatever. So IV is what? Is the voltage across this resistor. So it is V naught over 10K plus We know V naught, so we could write it directly. .7, and IB is VB, which is 0.9 over 50. Okay. So if you simplify, then you get 0.288 milliamps or 288 microamps. This is your final answer for I naught. So I hope this explanation simplified the solution of this problem. Good luck.